Hello again. This week, Phil and I are going to try and do a video together. We've had our challenges. There's about 25 centimetres different in height between us, but we'll see how we go. We're having fun, so we'll see how it turns out. What we want to talk about is applications of functions, and particularly as they relate to Senior Maths B. Now, when we talk about applications, and if you look through the syllabus for Senior Maths B, it's replete with references to having applications. So you can't teach Maths B or indeed Maths A or Maths C without doing applications. But when we talk about applications, we need to be careful that we choose things that are actually relevant and meaningful for the students. So often we have applications that the kids don't relate to at all. And they fail to build that sort of sense of connection and engagement that we're hoping for. So how do we connect to what the students might be interested in, and how can we make sure it's authentic? Sometimes the applications we see are so contrived that really it just looks like a fake maths question with some sort of disingenuous sort of application. Now, applications can be used in a range of places. They can be used to introduce new topics or concepts or ideas, or they can be used later on in the course to assess once they've learned the topic. But often if you introduce it at the start, it's a way of the students to see that it's useful and relevant somewhere, and it gives them sort of a paradigm case to try and connect their learning to. Certainly as we think back to the general capabilities of the new curriculum and the general objectives for this curriculum, the MAPS part is fundamentally about applications. So now Phil's going to come in and give you some specific examples.
Thank you, Peter. One of the examples I like to use from time to time is, in terms of functions, is a little concept known as light attenuation. In other words, how light is broken down or spread apart as particulates in the water spread that light. And if you think about some of the applications of that, if anyone's doing any recreational diving, if anyone's looking at the productivity of seagrasses as a food source or photosynthesis that happens, the amount of light that gets down to the bottom of the ocean obviously becomes less intense as the depth increases. So a little activity I'd probably do with some kiddies is an exponential equation. And that equation, as you can see, there's an exponential one where your light intensity at a particular depth is dependent on a couple of things. One is at exactly what depth of water we're talking about. What the light intensity is at the surface. It might be a nice sunny day, it might be a cloudy day, rainy or whatever that is. You might be looking at different parts of the earth where the light intensity changes. And the other thing also depending on the constant, and if you do some more research into that, the constant might talk about the temperature, etc. So let's just say that we've got a situation where we've got a sunny day, and we know that through our measurements that at say a depth of 10 metres, our light intensity is 75% of what it was at the surface. The question is, what's the light intensity then of at 20 metres? And we might relate this to, we might have a known piece of information about what types of plants need a minimum or a maximum amount of light in order then for them to reproduce. And so we might want to know what the light intensity is going to be at a depth of 20 metres. Why is that important? In some parts of Australia now where we've got coal being loaded onto ships at a particular port, and the dust that is blown off the loaders, that then goes into the water, changes the amount of particulates in the water, and what effect does that have on sea life in that particular place? Look, here's the solution. You can come back to it any time, just pause it, have a look at it. But we're just going to be using the equation, the function there, to solve a problem. And so at a depth of 20 metres, the light intensity is going to be about 56%. Well, so what? There's a picture there of the HMAS Brisbane that was sunk quite a number of years ago off the coast of Queensland. And the environmental engineer, I know he was looking at a particular place, and he had to find one so that the amount of light was able there to sustain sea life, then became a recreational place to dive. And so the maintaining of the life ecosystem in there wasn't going to be wasteful by sinking a multi-million-dollar ship. And so we can start using our solving equations and functions to make it meaningful and engaging for the kids. Thank you.